when you have a circle on a graph and you have a straight line, that straight line can intersect the graph at two separate points. It can just touch at one point, like a tangent, or it can not touch at all. So what do you think you're going to have to use to work out how many intersections there's going to be? Or there are going to be? Yeah, there are going to be. What do you think you're going to have to use? Discriminant. So that comes up again in this topic. But yes, that is the basics. That's the foundation. And now we're going to build upon that. We're going to have a look at questions that make use of this. So it says in this question, find the coordinates of the points where the line y equals x plus 5 meets the circle x squared plus y minus 2 squared equals 29. Okay, here's what you're going to do. You're going to solve this simultaneously. So can you try it? Can you try and solve this simultaneously, please? You've got your straight line in terms of y, right? So you can just sub that in. So when you sub it in, you get x squared plus x plus 5 minus 2 all squared equals 29. And from here, you're just going to simplify and solve. So you end up with x plus 3 all squared equals 29. When you expand and simplify, you get 2x squared plus 6x minus 20 equals 0. All of my terms are divisible by 2. X squared plus 3x minus 10 equals 0. And now, when you put it into brackets, x plus 5, x minus 2. So x equals minus 5, x equals 2. Plug that back into your straight line equation, y equals x plus 5. So here, y equals 0. And when x equals 2, y equals 7. There you go. Those are your two coordinates. Easy as that. Okay. Show that the line y equals x minus 7 does not meet the circle, blah, 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 blah. You're going to do the same thing as we did just before. You're going to try and solve simultaneously. But here's what I want you to do. I want you to end at the simplified quadratic. So your quadratic being x squared plus blah, blah, blah equals 0. That's where I want you to finish up. And then you're going to see what you can do to figure out how many intersections there are going to be. Okay, try that. So you plug in y equals x minus 7. X minus 7 all squared equals 33. You're going to expand and simplify. When you expand both and simplify both, you end up with this. That's after taking the 33 to the other side. And then you're going to divide everything by 2 because you can. You end up with that. Now, it says, show that the line y equals x minus 7 does not meet the circle, which means our quadratic, when we use b squared minus 4ac, we're expecting it to be less than 0. That will show no intersections. A is equal to 1, B is minus 5, C is 10. So minus 5 all squared minus 4 times 1 times 10, which gives us 25 minus 40, which is minus 15. Minus 15 is less than 0. There you go, no intersections. So it doesn't touch the equation, or it doesn't touch the circle at any point. Cool. Have a look at these two questions for me, please. And I want you to give those two a shot. Okay, let's start with question 4. First thing I'm going to do is rearrange that first equation, x plus y plus 5 equals 0. I can rearrange that to y equals minus x minus 5. You can rearrange it for x, but I chose to rearrange it for y just because that's what we've done previously, and it helps to keep things the same. Now, I can simplify this equation, that second one, by doing the completing the square method. So x plus 3 all squared plus y plus 5 all squared equals 65. Okay, technically, if I were to break it down a bit more, you should have minus 9 here. Here you should have minus 25. And then you've got the minus 31 that's already there. So here would be the minus 31. That together will give you 65, and then you take that to the other side. Okay, so now you can sub in the minus x minus 5 and then plus 5 all squared equals 65. Okay, so now x plus 3 all squared plus minus x all squared equals 65. You're going to expand, simplify. That will take you to 2x squared plus 6x plus 9 equals 65, which makes 2x squared plus 6x minus 56 equals 0. Divide it all by 2. X squared plus 3x minus 28 equals 0. So x equals minus 7. X equals 4. Once you sub those back into your first equation, when x equals 7, y equals 2. And when x equals 4, y equals minus 9. So the line x plus y plus 5 equals 0 intersects at these two coordinates. Cool. Question 6. Show that the line x plus y equals 11 meets the circle with equation blah 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 at only one point. So we're going to rearrange that first one into y equals 11 minus x, and then we're going to sub it into the circle equation like this. You're going to expand, you're going to simplify, you end up with (32), like that. Move it over. like this. Divide it all by 2 because you can. And then solve. Like this. Which means you only have a one solution. Okay. Find the coordinates of the point of intersection. Well, you just found the x. To get the y, you just sub it in. So y equals 11 minus 4. 7. 4, 7. That's how you get the points of intersection. And that is how you do intersections of straight lines with circles.